Okay, so we're going to be on notes 4.4, finding the inverse of a matrix. We're going to be using that later on to solve a system of equations using an inverse. Okay, so it says inverse is if the product of two matrices is the identity matrix. So remembering back the identity matrix, the diagonal from left to right are ones and all the other elements are zeros. So on a 2 by 2, if you end up with this, then you know that they are inverses when you're multiplying them. A 3 by 3, the diagonals, again, diagonal from left to right are ones, and then everything else are zeros. Okay, so this example here, we're given two matrices. It says, are these inverses? So what we need to do is we need to multiply them and see if we get the identity matrix. If we do, then they are inverses. So remember, whenever you're multiplying, you need to check your order. This is a 2 by 2. This is a 2 by 2 also. So the insides match. Our answer will be those outside numbers. Okay, so when you're multiplying two matrices, you're multiplying rows by columns. So I'm going to multiply the first elements together. So that's 2 times 2 over 7. We're not finished, so plus. Multiply the second elements together. 1 times 3 over 7. And notice we're finished with that row and column. So now I'm going to go over to that second column. So I'm still in the first row, but second column here. I'm going to multiply the first elements, 2 times 1 over 7. And then multiplying the second element, 1 times a negative 2 over 7. I'm finished with that first row. So now I'm going to multiply the second row by this first column. Multiplying the first elements, 3 times 2 over 7. Plus negative 2 times 3 over 7. And then multiplying by that second column, 3 times 1 over 7. Plus a negative 2 times a negative 2 over 7. Okay, so now we need to multiply and then add them up. When I multiply this, that's going to give me 4 over 7 plus 3 over 7. So when you're adding fractions, you're adding only the numerators and you have to have a common denominator. So notice we do have a common denominator. So when we add 4 plus 3, we get 7 over 7, which equals 1. On the second one, 2 times 1 over 7 is 2 over 7. 1 times a negative 2 over 7 is a negative 2 over 7. So notice 2 sevenths minus 2 sevenths is 0. So we get a 0 there. Multiplying these together, that's going to be 6 over 7. Multiplying these together, that's negative 6 over 7. So that gives me 0. Looking over here, this is going to be 3 over 7. That would be minus 4 over 7. Or positive, sorry. So you should get 7 over 7 here, which does equal 1. So notice when we multiply these two together, we get the identity matrix, because the diagonal from left to right are ones, the other elements are zeros. So we would write yes, these are inverses of each other. Okay, so if it asks if two matrices are inverses, multiply them. If you get the identity matrix, you know they're inverses. Okay, a to the negative 1 power. That is the symbol used for inverses. Okay, remember the symbol for determinant are the vertical bars. Okay, the symbol for inverses are your matrix to that negative 1 power. The formula to find the inverse of a 2 by 2 matrix, you're given a matrix that looks like this, A, B, C, D. We talked about that yesterday. To find the inverse of that, you're first going to find the determinant. Remember to find the determinant. The formula is AD minus BC. So we're first finding the determinant. Then we'll use this formula here. We're going to do 1 over whatever that determinant is that we find. And then notice we've rearranged the elements of the original matrix. Notice A and D, we need to switch. And then we change the sign of B and C. That's why it says negative B and negative C. So you'll have to do that. Once you've plugged it into that formula, you will distribute this scalar. Because remember, a number on the outside of your matrix is a scalar. You'll distribute it to all of your elements inside your matrix. That should give you your inverse matrix. All right, if the determinant of a matrix is 0, it does not have an inverse. Okay, the reason for that is if we were to plug in a 0 for the determinant on this formula, 1 over 0 is undefined. We can't divide by 0. Okay, so this first example, we're going to find the inverse using the formula. So the first step in order to find the inverse is to find the determinant. So I'm going to do negative 9 times a negative 3. Remember, you're subtracting, and then 5 times 6. So that would be positive 27 minus 30, which gives you a negative 3. So we found the determinant. Now we're going to plug it into this formula that we were given right here. So I have, I'm just going to call it A. Inverse of A will equal 1 over the determinant that we found, which was negative 3. And then I'm going to set up a matrix here. Remember, we're not just using this matrix. We're having to rearrange and change the signs. So A and D, we need to switch. So now this first element will be negative 3. This bottom right will be negative 9. Also, you have to change the sign of B and C. So that's a negative 5 and a negative 6. You don't change the position. You only change the sign of that. Okay, so now what I will do is I will distribute this scalar here on the inside to every element. So negative 1/3 times a negative 3 would give you a positive 1. And then a negative 1/3 times a negative 5 would give you positive 5/3. Leave it in fraction. And then negative 1/3 times a negative 6 would give you a positive 2. Negative 1/3 times a negative 9 would give you a positive 3. So there's our inverse of our original matrix. Now, if you wanted to check and make sure that is the correct inverse, remember you can multiply these two together. It should give you the identity matrix if those are inverses of each other. So you can check it by multiplying them. Okay, let's look at example 2. So first step, find your determinant. So the determinant, we're going to do 6 times 8 minus negative 16 times a negative 3. So that's going to be 48. Bring down that subtraction sign. A negative 16 times a negative 3 is a positive 48, but we were subtracting them. So we get 0 here. So if we're finding the inverse and we plug into the formula, notice we cannot divide by 0. That's undefined. So if your determinant is 0, you know that you will not have an inverse. So you can write no inverse. So there's not anything times this matrix that will give you the identity matrix, because there's not an inverse of that matrix. Okay. All right, the back, it summarizes everything that we've gone over of how to find by hand, how to plug it into the calculator. Anytime you have a 2x2, you're always going to do it by hand. Anytime you have a 3x3, you can use the calculator. So example 3, we're going to use our calculator to find the inverse of this matrix. Okay, we haven't learned that yet. So here's your steps right here. You're going to first plug in your matrix. So we went over that yesterday. So second matrix, we're going to go to edit. I'm just going to type it into matrix A. It's a 3x3. Make sure you're checking every element as you plug it in. 3, 0, -2, 1, 1, 5, -3, +2, and -1. Again, check your elements before you move on. All right, so we typed in our matrix. Then you're going to go back to your home screen. You're always going back to your home screen anytime you're trying to find something of a matrix. So second, quit. I'm going to do second matrix. I'm going to name A, because that's where I put it. And then the X to the -1 button, which is what we usually push after our second key. We're not going to use second, we're just going to push X to the -1. So you should see A to the -1. Remember, that's the symbol to find the inverse. So A to the -1, you press enter. Now notice that you get lots of decimals here. I want your answers in fractions. So what you can do is once you find that matrix, you can go to math, fraction, press enter, and then it finds your fractions for you. Get this calculator moved over here. Okay, so that's going to be 11 over 43, 4 over 43. I'm going to go ahead and write the ones that I'm able to see. And I'll move over. That's -2 over 43, 17 over 43, and -3 over 43. Okay, so if we wanted to check and make sure that is the correct inverse, we could multiply these two together. When you multiply them together, it should give you the identity matrix, okay, if that is the correct inverse. So you have the instructions on your notes so you can refer back to those instructions in order to learn how to plug in on the calculator.